So yeah, I'll be talking a little bit about a workflow manager that's developed at Argonne called Balsam, and how it can help you manage large campaigns of high throughput workloads on our systems. I'm going to give a very brief hands-on demo that you can feel free to follow along with, or run examples from GitHub at your own pace. And after me, Antonio will follow up with a discussion of Parcel, which is another approach based in writing Python scripts. So in a nutshell, Balsam is a service and a workload manager that allows you to submit a large number of tasks and define the resources that they need in a fashion that's decoupled from the resource allocation. So rather than submitting job scripts and worrying about managing ensemble jobs yourself, you write simple commands or use a Python API to submit commands to a database that belongs to you. And then once you have this database of tasks to run, you can acquire resources and manage the execution of these tasks in a very efficient way that makes better use of resources than you would if you were just running, simple ensemble jobs, running, one job per node or something like that. So the way it works is really you start by loading a module on Theta and creating a database. So I'm going to jump right into that. If you have access to the GitHub repo, I would encourage you to start here. So at the very top, we'll go into the first session here under 00_workflows. And here you'll find the top page with folders for Balsam and Parcel demos. So under Balsam, if you take a look, there's a short README on how to get started. On Theta, I would encourage you to enter the grand project space. So if you go into LUS, grand projects, we have a space for the Comp Perf workshop. So here I've already created a directory for myself. In this space, you can clone the GitHub repository and enter the Balsam demo folder to follow along. So we start just by loading the Balsam module. This will give you a Python environment that has Balsam installed, as well as the underlying database. And you can create a database with this command Balsam init. So what this does is creates a new directory, which I've already done. As you can see here on the right-hand side, I have a test DB, and this will contain a sandbox where each task will run in its own local working directory, and it'll have logs containing information about the workflows that you've run and the database itself that is kind of the engine behind all of this. So once you've created a database, you'll set the context with this source Balsam activate command. This kind of follows the conda activate if you're familiar with that shell command. And what this does is it actually starts up the database process on the Theta login node and sets the shell environment so that you can run commands against that database. So with that, I'll jump into the tutorial. So what we do, one of the common ways of interacting with Balsam is through a command line interface. So that's kind of where I start, although there are more powerful ways of querying and creating jobs with the Python API. So the first thing you can do is run this command Balsam which. And this tells you what database is currently active. So you can see I've run Balsam which, and it tells me that I have a database directory here, testdb, and it tells me that the service is running on this Theta login 4 and this port. And that's handled for you automatically when you run Balsam activate. The first thing we do with the database is define what applications can run. So this Balsam application is kind of a template for the commands which can run. And here I'm going to do sort of the hello world example of Balsam, which is to create a new application that I call hello. So if you can see here on the right-hand side, let me know if the text is too small, by the way, and I can blow up the screen a little bit. So I'll create an app.
I would suggest you to do so.
Yes. How's that?
Much better.
Great. Okay. So here I'll create a Balsam app with and I give two arguments here. The name is hello, which is an alias for this application we'll refer to later. And then the executable. Now this would be, the path to your application code or some script that you want to run. In this case, I'm going to set it up as just part of the bash built-in command echo with just the word hello there. So this is the beginning of our application template, and we can append other arguments to this. So you can see where this is going. We create this hello application, and you can see here that the fields populated are the name and the executable, and there are other optional components of an application that I've left out for this simple example, but follow-up tutorials online will show you what you can do with those. So once you have an application defined, it lives in your Balsam database forever. So this is a one-time operation for defining new applications. And you can see when I run Balsam ls apps, I have a couple of applications here. This hello application is listed as number 2, and my table shows there that it's just running this echo hello command. Now that I have it, the next step is to define a couple of jobs to actually run the hello application. And the way we do this is with the Balsam Job Command. So here I can show you, let's say I want to create one instance of the job where we want to say hello world. So the way to do that is to create a job with a certain identifier. That's, again, a name. So I can call it hello world. And a workflow is another part of the identifier. I'll call that demo hello. And I want to refer to the application alias, which in this case up here is called hello. So I have to use hello for the app argument. And then finally, I give the arguments. So for the arguments, I'll say in single quotes, world with exclamation mark. And you can see that you get this large task confirmation, which shows many fields that we've left out that default to reasonable default values, the name and workflow of our application, and at the very bottom you can see the command that's executed, right? So this is just echo hello world, and a working directory has been generated for us. So I can do this one more time with another job. So let's say in this case I want to say hello workshop. So I'll give it the same name, but a different name, but the same workflow. And we're going to run this hello application. And then the args now will say workshop instead. So again, I confirm. And if I run now Balsam ls, which is shorthand for Balsam ls jobs, you could see here in this tabular view, I have, oops, disappeared. So yeah, I have my jobs that have been created. So now there's a lot of fields on the job, as you can see up here, right? A lot of things you can define, but the key ones are this name and workflow, which go into the generation of the job working directory. So you can see the working directory here ends up falling under the Balsam database that I've created and this data directory. And the specific subdirectory for each job is created as this workflow, which I call demo hello. And then the name of the job, which is just hello workshop in this case, with some part of the ID appended here. So by setting the name and workflow, we're sort of implicitly creating a space for the job to run. So this combination of name and workflow should be unique, and we can group related runs by having the same workflow name in Balsam. So the app, again, has to always refer to one of the application definitions that we've created. The arguments are command line arguments. And then, yeah, we can pass additional context here, like, for instance, the ranks per node to set the number of MPI ranks per application. In this case, obviously, that's not a relevant parameter. But Balsam jobs contain all the metadata for not only the application that's run, but the environment of the application and any parameters that pass through to the MPI launcher to run the job. So Once you've got your jobs created, I've showed listing them. We can also show additional arguments in the list by setting this environment variable here. If I add Balsam ls fields and I add, for instance, the args, let's say ranks per node, I can run Balsam ls again, and I'll get additional context in my table view. So for instance, I can see the different args for these two jobs, and then they both run ranks per node. I can also do things like modifying jobs. So I can, modify, say, this second job, hello workshop. I could take the first few characters of the ID and say, I want to make ranks per node 2. So what this did is change the job ranks per node per 2. This is not something that you would, normally want to do for an echo job, but what this will just do is run it the same command in 2 processes. So it's kind of a taste of listing and modifying jobs from the CLI. Now, ultimately, what you want to do is make these things run. So you could see that they're stuck in this created state, which is basically the beginning of the life cycle for each job. So Balsam jobs run through a number of states, depending on how they're processed and where they are in the pipeline. They start out being created, and ultimately we want them to start running and hopefully finish successfully. So the way to actually get some compute nodes and start running is to use this Balsam submit launch command. So Balsam submit launch is really kind of taking the place of qsub. It's what you would run in the place of qsub, and Balsam will do the qsub under the hood for you. So we would still use the same queue and project. So I believe, let's see, so we want to run this, just have the name of the queue and project in my history here. So I would do Balsam submit launch onto the workshop queue and allocation. You replace this with your own project allocations in the future. And then again, you ask for the wall time for the number of minutes. So here I'll ask for 5 minutes. And see, I have in my example just asking for 1 node. And then there's this job mode argument that you set, -- job mode, which controls how the underlying pilot job actually pulls and runs applications. So in MPI job mode, we're able to run, we use app run for each job to run on a set of compute nodes. And in this way, we can run something that has 2 ranks per node. So when I run submit launch, it should generate the script and submit a job for me. And this job is just going to, whoops. Maybe I'm not part of that group, so I can try a different one. Maybe something wasn't set up for me correctly. Let me try a debugging queue. So that should work for folks as long as if they can run qsub with a certain queue and project, then the same submit launch command should work. There we go. So using a different queue that works for me, you can see I've got a submission that went through with this.
Misha?
Yep.
Just a heads up that the computational performance workshop queue on Theta KNL is not working for anyone right now. Just
okay.
So they're working on it.
Oh, thanks, Kyle. So yeah, hopefully, once that queue is up and running, feel free to use it. I've just submitted to a debug queue under a different allocation. Once my job is queued, it will begin to pull the jobs from the database and process them. So inside of this database directory that I've created, I can see a number of directories here. This data directory again will contain the job working directories, and this qsubmit folder is actually where my job script was generated. So this qlaunch2, which was my second submission attempt, you'll see has the shell script that's written and submitted under the hood. And you'll see that it doesn't actually run my tasks directly. It just runs this Balsam launcher, which will do everything for me. It will pull jobs from the database and run them across the compute nodes efficiently. So one thing, you can monitor with, again, it looks like my job started because I've run Balsam LS. Now one is pre-processed and one is done. So I can maybe watch Balsam LS, and okay, by now both jobs are finished, which is good. So what I can do now, to jump into the directory of a job and see the output, there is a shortcut command here, this source or .bcd, and then take the first few characters of the job ID, like so. So I want to cd into the directory of job hello world, which has this ID bb2, and then that will take me there. Of course, that's just a shortcut for going in there yourself. And then I can look at this hello world.out, and I see that my output is there. And again, with Balsam LS, I can see both jobs being finished at this point. So that is, a first taste with the command line interface. I would encourage everyone to move on and take a look at the Python API in Balsam, but I want to make sure we have enough time for Parcel and Q&A. But just to briefly show this without actually running through it, if you had a large number of simulations to run, for instance, you wouldn't normally want to write a bash script to go and populate the database for you with commands like I've just done. It's typically much nicer to use the Python bindings to Balsam that let you do this by sort of directly interfacing to the database. So if you look at the next page here in the documentation, again, there's examples for this in the GitHub repo. What we can do is import this Balsam job and application definition models from the Python library, and we can use these things to create new applications and define applications programmatically. So here I have this job that all it does is it takes a number as input and squares the number, and I have a script that will create a range of these to print some list of squares, and then you can run this script to both populate the database and then actually run the calculation. So there's a full code example here, and please do give it a try and let me know on Slack if you have any questions. We'd be happy to help out. So with that, I'll turn it over to Antonio to talk about Parcel.